Good morning, students. Today we are going to start our chapter mole concept. This is the first chapter of 11th class, which you should know that why this mole is very much important for chemistry. This is the biggest thing, that why it is very much efficient for it, why it is necessary for chemical reagents, that we always going to calculate the quantity in terms of moles. First of all, you understand, Babu, that mole is a quantitative term. It is a quantity based term. Means it tells you about amount of substance. Mole is basically used in chemistry. Suppose if you go for SI units, in SI units, the SI unit of mass, you already know it is of kg. It is already written there. And normally in all other chapters, the amount will be defined in terms of mass, and mass is having SI unit kg. But in chemistry, we don't use mass as an amount term. Our major effect is of moles. Mole is basically an amount term apart from mass, and it is defined as the SI unit of the amount. Means the SI unit of amount is mole. This is the biggest thing. So suppose if we are going to write it like this, you may be able to understand more easily about this one. Suppose I say, what is the SI unit of amount term? You will say it is mole. And this mole is basically used in chemistry. Now your next question is, can you tell me, sir, why mole is so much important in chemistry? Wait a minute, I'm going to tell you. The necessity of mole arises because we use chemical reaction terms. We basically use the chemical reaction terms where the chemical reactions are balanced. The balanced chemical reactions are having their stoichiometric coefficients. You already know. Suppose a chemical reaction is given like this: 2A plus 3B gives 4C plus 5D. Suppose it is balanced chemical reaction. And these 2, 3, 4, 5, these are called as stoichiometric coefficient. So initially what it is being defined, it is being observed, or it is being assumed that old concept, I'm going to tell you about the old theory. Initially it was thought that this stoichiometric coefficient will represent mass. What it means? Means it is assumed that when you mix 2 gram of A with 3 gram of B, you will get 4 gram of C plus 5 gram of D. But when you have done the experiment over this reaction, you will come to know that this concept is not correct. Means the stoichiometric coefficient will not represent the mass of a chemical substance. So what this stoichiometric coefficient will represent? Then Avogadro, the scientist Avogadro, and many other scientists are also there, they have defined a new concept of amount, and that is called mole. Now why mole is necessary? I am going to tell you. This stoichiometric coefficient will actually represent the moles. Means if we say that 2 moles of A reacts with 3 moles of B to give 4 moles of C plus 5 moles of D, and when we do the experiment over this particular quantity term, we come to know that it is correct. Because when the theory and the experimental results both are coming inside and they will give the similar results, definitely that concept is acceptable. So what happens now? We come to know that these stoichiometric coefficient will represent the moles of the corresponding chemical reagent. Now this is why the mole is so much important in chemistry. Now the next thing is that how you are going to calculate the mole. I'm going to tell you the basic formula for moles. You already know this thing, but I'm going to tell you the important basic concept. What is that? Please try to understand. Mole. The formula for mole is, it is practical weight by theoretical weight. What is practical weight? The practical weight is that weight which you are going to take for the experiment. This is in your hand. You can take 20 grams, 30 grams, 40 grams. Theoretical weight is not in your hand. It is already defined. Means, suppose I am going to use this formula for atoms. So what is the formula for moles? The moles will become now, this practical weight, we are going to write it as weight, and the theoretical weight for atoms is the atomic weight. Similarly, when we are going to write for the molecules, you know already that the molecules is having molecular weights. Then we write the same formula as mole is equal to weight upon molecular weight. Now, the weight which you are written above in the numerator, it is the practical weight. I am going to tell you the answer. One experiment, one particular example. Wait a minute. Now, if we are going to discuss the example of this particular concept, suppose we are going to take 20 grams of CO2. CO2 is a gas. 20 grams of this 20 gram is a practical weight. Means, suppose if I have to write the moles of CO2, what is that? It is 20 upon, and the molecular weight of CO2, it is already known to you, it is 44. So 20 by 44 is the moles of CO2. Now you come to know this one. This is a quantitative term. Means the CO2 is having this much amount of moles. Means weight upon molecular weight. I hope so you understand this one thing. But one condition is there. One very important condition is there which I am going to tell you just now, and it is not written anywhere, but you should be very careful. That is called VK alert. What is the VK alert? I am going to tell you. The VK alert is that VK alert. Don't use this formula, mole equal to practical weight by theoretical weight. Never use this formula for subatomic particles. What are the subatomic particles? Electrons, protons, neutrons, and many other mesons, pions. What is the smallest massful object? So never use these formulas. Which is a smaller massful object in chemistry? The smaller massful object is either quarks or you can say Higgs boson. Smallest massful forms. Never use these formula for this subatomic particles, otherwise you will get the wrong answer. Remember, this thing is a very important thing, and I am giving you one example. Suppose in any question, this is once it comes in IITJ Advanced, and I think so very soon it is again going to come in your IITJ Advanced paper. What is that? Suppose I give you 20 gram of electron. Please listen, 20 gram of electron. Now, this 20 gram of electron, you want to convert it into moles. What is the mass of one electron? You already know the mass of one electron is 9.31 into 10 to the power minus 31 kg. Convert it into grams. So it will come to be 9.31 into 10 to the power minus 28. This one grams. This is the mass of electron. Now suppose if you are going to use the same formula for electrons, moles is equals to, you are saying that 20, it is in grams. Now write this one thing is also in grams. It is 9.31 into 10 power minus 28, and you will say that it is the mole of electron. So I am telling you, this is wrong. Never use this formula for the subatomic particles. Any subatomic particles, electron, proton, neutron, never use this thing.